In 1930, Soviet officials demanded a machine so powerful it would shatter the limits of Western rail, a locomotive built not from engineering need, but from a single political order. The official story celebrated a triumph, the largest steam engine in European history, a marvel with 14 driving wheels, and an impossible promise to move the USSR into the future. But behind the headlines, disaster brewed. Rails bent, budgets derailed, urgent warnings ignored, yet the dream pressed on. This was more than a mechanical gamble. It was a test of truth versus ambition. What really drove the USSR to gamble everything on a locomotive that history tried to erase? The answer begins where propaganda met steel. In March 1930, a directive landed on the desks of every major locomotive design bureau in the Soviet Union. The People's Commissariat of Railways, acting under orders from the Central Committee, demanded an answer to a crisis threatening the very core of Stalin's industrial ambitions. The numbers were stark. In Donbass, coal shipments fell short by over 6 million tons. The Central Industrial Region missed its target by 12 million. Across the Urals and Volga, deficits piled up, more than 30 million tons of freight undelivered in a single year. The official order left no room for debate. All design bureaus were instructed to prioritize the development of high-capacity locomotives capable of hauling unprecedented loads. The language echoed from the top: new engines must outmatch American and European models in both tractive effort and tonnage. Delivery and testing deadlines were fixed within the current 5-year plan. The typed memorandum even included the line, "Set a record for the socialist railways," underlined in red pencil. For the engineers at Voroshilovgrad and Kolomna, this was more than a technical challenge. It was a non-negotiable command, issued in the shadow of missed quotas and the looming threat of being labeled an obstacle to progress. Failure to comply risked accusations of sabotage, a charge that, in Stalin's Soviet Union, could end a career or worse. Behind the statistics, the pressure was relentless. Every day lost to bottlenecks threatened new factories, military shipments, even the success of the 5-year plan itself. The demand for a world record locomotive was not born from the needs of the rails, but from the needs of the regime. In the months that followed, blueprints would be rushed, budgets stretched, and warnings silenced. The AA20 began not as an invention, but as a decree. Gudok, the railway newspaper, rolled out headlines in bold type. "This machine will redefine world steam power." Pravda echoed the excitement, hailing a new era for Soviet industry. The press became a chorus, each headline louder than the last, promising a locomotive so powerful it would silence Western critics and carry the 5-year plan on its back. Day after day, blueprints appeared in newsprint, long shadowy silhouettes with more wheels than any engine seen before. Diagrams stretched across centerfolds, showing a wheel arrangement with 4 lead wheels, 14 driving wheels, and 4 trailing wheels that dwarfed the workhorses of Europe and America. Readers saw sketches of the AA20 boiler, its 7 massive driving axles, and a length that spanned over 130 feet. The message was clear: this was not just a locomotive, it was a national event. Deadlines grew tighter as the project was tied to the anniversary of the October Revolution. Editors counted down to unveiling day, running stories about the workers at Voroshilovgrad and Kolomna racing the clock. Each article praised the engine designers for their loyalty and brilliance, while party officials posed beside scale models declaring the AA20 would crush all capitalist records. Propaganda posters plastered factory walls and city squares, showing a colossal engine charging across the steppe, red banners streaming behind. Children in schools were taught to memorize its specifications. Even the smallest towns heard the story: Soviet power made real in steel and steam. Yet behind the spectacle, the pressure mounted. Engineers were ordered to meet impossible dates. Every missed milestone risked public embarrassment, or worse. The AA20 was no longer just a machine, it was a promise broadcast to millions that Soviet science would triumph no matter the cost. Inside the design bureaus, the AA20's blueprint became an object of AWE and anxiety. 7 massive driving axles, 14 coupled wheels, stretched across a rigid frame longer than a city bus. The technical drawings, stamped with the Voroshilovgrad factory seal, showed a machine measuring over 130 feet. At its heart sat a boiler so large it required a radial firebox and an expanded grate, pushing the limits of Soviet metallurgy. Every measurement on the page seemed exaggerated, yet each was signed off under the pressure of the Central Committee's deadlines. The 7-axle driving frame was the bold gamble. Soviet engineers knew that such a long, unbroken wheelbase would struggle on the country's tight curves and light rails. To keep the engine from tearing itself and the track apart, the team introduced a rare solution. The middle 3 axles were fitted with flangeless wheels known as blind drivers. These allowed some lateral movement, offering a slim chance of negotiating the bends found across the southern main lines. Still, the sheer length of the rigid wheelbase, unmatched by any locomotive in Europe, meant that even small curves could become dangerous obstacles. Transmitting power across all 14 wheels required a system of side rods with built-in universal joints. The rods had to flex and pivot, compensating for the inevitable misalignment as the engine rolled over uneven track. Each coupling rod was forged from high-carbon steel, machined to tight tolerances, and assembled by hand, a process that stretched the limits of Soviet industry. The 4th axle sat at the center of the drive, bearing the brunt of the tractive force, while the outer axles relied on careful balancing and precision engineering to avoid catastrophic binding. Even on paper, the AA20 strained the boundaries of what Soviet rails could support. The typical mainline rail weighed just 43 kilograms per meter, far lighter than those used in the United States. Engineers calculated that the axle load would need to stay under 20 tons to avoid immediate track failure, an impossible target given the engine's mass. Every new revision to the blueprint brought more warnings, but each was overruled in the rush to meet political expectations. In the end, the AA20 was less a locomotive than a rolling experiment in physics, its every detail a compromise between ambition and reality. In the heart of the Voroshilovgrad workshops, engineers hunched over blueprints already knew what the headlines refused to print. The AA20's weight, sprawled across 7 rigid driving axles, would press down on Soviet rails with a force never before attempted. Most main lines across the southern Soviet Union were laid with 43 kg per meter rail, a section far lighter than the steel found under American giants. In the spring of 1932, a typed factory memo circulated among the senior designers. Its language was careful but unmistakable. The memo stated that Soviet rails are not American rails. They will not hold such weight. The warning, signed by several workshop engineers, outlined the danger in plain terms. Calculations showed that even under ideal conditions, the AA20's axle load would push the rails to their limit. Any unevenness, any minor defect in the track could cause the rails to spread or buckle. The memo did not stop at numbers. It described the likely outcomes: cracked switches, derailed trains, the risk of catastrophic failure during routine operation. The engineers urged a redesign, shorter wheelbase, lighter frame, perhaps even abandoning the 7-coupled arrangement entirely. But the deadlines were fixed, and the political spotlight was blinding. The memo was acknowledged, filed, and quietly set aside. Within days, the workshops resumed full pace. Riveters hammered, welders sparked, and the frame of the AA20 took shape on the factory floor. Official correspondence from the period reveals a pattern: warnings acknowledged, then overruled. The project's managers, facing pressure from above, chose to trust in optimism and improvisation over technical caution. The AA20 would roll out on schedule, no matter what the calculations said. In the silence that followed, the engineers returned to their benches, their caution buried beneath layers of steel and secrecy. The locomotive's fate was sealed not by accident or ignorance, but by a conscious decision to ignore the alarms. The AA20's first trips onto the test track brought a new kind of alarm, one that echoed through the rails themselves. Inspectors logged measurements as the giant engine rolled past at low speed. Within minutes, the rails began to spread under the pressure. The gauge widened by several millimeters, enough for the track to flex and groan. On a line built for standard freight, the AA20's 140-ton frame pressed down with such force that even the heaviest sections, 43 kilograms per meter, could not hold their shape. A test log from the Kolomna to Ryazan line recorded the first failure. A turnout switch shattered under the 7th axle, its points splintering as the rigid wheelbase forced the rails apart. The crew halted the engine and watched maintenance teams scramble to replace the mangled steel. By the end of the day, 2 more switches had failed, each one unable to handle the combined effect of the engine's length and weight. Load measurements from the inspectors told the same story. The axle load, meant to stay under 20 tons, regularly spiked above that limit as the locomotive crossed uneven track. In some sections, the rails bent visibly, leaving a permanent kink that had to be hammered flat before regular traffic could resume. The test logs show a clear pattern. Each run left behind a trail of bent rails, cracked joints, and broken fastenings. The infrastructure damage mounted quickly. Every attempt to route the AA20 through a yard or over a switch ended with a work crew called in to repair the aftermath. The engine's sheer length and unyielding frame turned even gentle curves into hazards. Inspectors began to document the failures in detail, measuring the spread of the rails, the depth of the grooves worn into the switch points, and the number of bolts sheared off by the passing behemoth. The physical toll was undeniable. Soviet track, already stretched thin by years of overuse, simply could not bear the concentrated force. The AA20 became a rolling test of limits, and the rails lost every time. Inside the cab of the AA20, the illusion of control vanished as soon as the locomotive picked up speed. Vibration meters, hastily mounted for the trial run, recorded amplitudes that climbed past safe thresholds within minutes. Crewmen braced themselves against the boiler walls as the floor pitched and rattled. The engineer's hands shook so badly he could barely keep hold of the throttle. It moves like a drunken elephant. Steam pressure, meant to be the engine's lifeblood, became a torment. At full load, the cycling system failed to maintain stability. Pressure spiked, then fell away, leaving the firemen scrambling to keep the boiler from running dry. The cab filled with heat and noise, gauges flickering between extremes. In the chaos, a warning whistle was drowned out by the roar of the cylinders. The brakes, oversized on paper, struggled to slow the mass of 140 tons. Stopping distances stretched far beyond what the test yard allowed. When the order came to halt, the engine slid past the mark, shuddering as the wheels locked and the rails groaned beneath. The maintenance log from that day reads like a list of confessions: axle box overheating, rod bearings loose, excessive lateral movement detected, crew requests immediate withdrawal. One technician, years later, recalled the moment the withdrawal order was issued. He said they were told to bring her in and not to speak of it again. The official recommendation, immediate removal from service, was stamped in red at the bottom of the report. For the men in the cab, the engine's promise had turned to dread. Each run was a test of nerves as much as steel. The AA20, designed to break records, had instead broken the crew's trust in what Soviet engineering could demand of its own people. The project's collapse was no longer a secret among those who had ridden in its belly. The only question left was how quickly it could be erased. Archivists searching for the fate of the AA20 find only a faint paper trail scattered across regional files and depot ledgers. After the final test runs, a transfer order dated late 1935 lists the engine by number: AA20-1, shipped under guard to a storage yard in Bryansk. The file is thin. A single receipt, stamped by the Bryansk depot chief, confirms arrival but omits any mention of its condition or intended use. For years, the locomotive sat on a remote siding, shielded from visitors and passing trains. Internal correspondence from the depot references a non-standard item to be kept out of public view. By the early 1960s, a disposal order appears in the inventory log for AA20-1, classified as obsolete rolling stock and authorized for dismantling. The scrapping invoice, if it ever existed, is missing from the archive. Only a brief note remains. It states unit disassembled, material recycled. No photographs, no ceremony, and no entries in the annual reports. The largest locomotive in Soviet Europe was reduced to a line in a ledger, erased as quietly as it had arrived. Museum catalogs from St. Petersburg to Moscow list hundreds of Soviet locomotives, each with photos, service records, and technical diagrams. But the AA20 is missing. Even the most exhaustive railway encyclopedias, published through the 1940s and beyond, skip from the FD class to lesser-known prototypes, never mentioning a 4x14 by 4-wheel arrangement with 7 coupled axles. In technical textbooks, pages on experimental engines describe other failures, but the AA20 appears only as a footnote, stripped of context and quietly misdated. Curators at the Central Museum of Railway Transport confirm that no official photographs or blueprints are on public display. When researchers ask about the AA20, they are shown a fragment of a drawing, no scale model, no plaque, no story. Modern historians searching for the truth find only gaps, missing catalog numbers, unexplained omissions, and a silence that feels deliberate. One expert calls it a lesson in engineered forgetfulness. The AA20's absence is more than an oversight, it is a warning written in missing pages. Steel can bend, but truth bends faster. Today, the line between ambition and illusion is thinner than ever, especially when power demands spectacle over substance. The AA20 story warns us. When ideology overrides engineering, reality is the first thing derailed. As global megaprojects multiply, that lesson grows urgent. Sometimes what is buried is not just a machine, it is the cost of truth. What do you think? Share your perspective in the comments below.